Hey everybody, welcome back. Level 2, Part 3, Full Circle System Design. We're going to take the elements that we learned of Level 2, Part 1, creating full circle solutions in the analog world, Level 2, Part 2, creating full circle solutions in the digital world, and we're going to put those together in some real-life applications as demanded by your clients today and tomorrow. So let's go ahead and begin. We want you to keep in mind the 5 bullet points, the 5 key bits of information that when you collect, you'll be able to put together a full circle video solution. Those 5 points are: what are the displays and how many? What are the sources and how many? What are the distances? Either the distance of every run if possible, or at least the maximum distance. What is the longest run? What is the desired format resolution, i.e. HDMI is the desired format, or VGA is the desired format at this resolution, perhaps due to existing gear, projector supporting resolution X. What is, and how would you like to control the system? Now, these 5 pieces of information are usually what you can gather just by looking at a system from abroad. Maybe it's something that's already existing. You know how many displays there's going to be. Maybe it's something that the customer, through your walkthrough and through your initial chat with the client, understanding what their expectations are of the system. Or maybe it's, for example, how would you like to control the system? Maybe it's something that you as a dealer have a preferred control system that you work with, and as such, we know that one of the 5 questions has an answer already. Okay, so you get those 5 bits of information, you're going to have a good platform for moving forward, good foundation. Now, if you'd like to be even more in-depth, you can go to keydigital.com and gather that System Design Group questionnaire. Remember, System Design Group, SDG, this is one of the really invaluable resources that we offer here at Key Digital, and we did discuss that in Level 1, Part 1. So how do you gather that questionnaire? You go to keydigital.com, you go to the technical section of the website, and you will see a link that says System Design Group Questionnaire. Now that expands it a little bit more. You're looking at maybe 10, 11, 12 questions on there, and this goes into a little bit more detail. And if you have this on you at all times, you know that you gather the answers there and you're going to be in really good shape. Okay? So let's go ahead and start thinking about the systems. And before we actually begin with our very first system, we want to discuss one of the most pertinent questions that you will confront, and that is the digital versus analog question. Now, we've gone over the solutions in either case, so you know that Key Digital has the hardware, has the solutions to enable the systems, whether it be digital or analog, and to achieve what your customer would expect out of their system. So let's just go over a few guidelines of when you're going to go digital. First of all, the client wants 1080p. Maybe it's due to just the overall marketing of 1080p, HDMI 1080p. Of course, 1080p is a resolution that is capable of being delivered through the VGA connectivity, as we discussed, even beyond 1080p, 1920 by 1200, and of course even higher resolution content is capable of going via VGA. However, we know that if the customer is just saying, I want 1080p, I want 1080p, I want 1080p, and kind of looking at it again, painting with the broad strokes, we know that that probably means they're looking at for an HDMI 1080p system. For 1080p, Key Digital has products that can deliver 1080p distances at 75 feet. That'd be the KD-HD-MSW 4x4. That's the matrix with the 4 included receive balance we discussed just in the last part of this section. 140 feet, for example, the KD-HDMS 4x4 with the BBTX, BBRX, 140 feet for 1080p. Or even just the BBTX plus BBRX in one-to-one applications. Also with our dual Cat 5 bound KD Cat HDX saying in the one source to one display, one input to one output systems as well, or even up to 300 feet using our KD Cat HD 500 HD base T technology balance. Now remember, if you have the option to run key digital Cat 6 cabling, your performance is going to increase. Not on the HDMSW 4x4, but once we go beyond that, you'll see some really big benefits by using the key digital cable. So you got 75 feet HDMSW 4x4, still the remaining distance. 250 feet for the BBTX, BBRX 1-to-1 applications, or through the matrix, the KD HDMS 4x4 Hercules series matrix goes from about 140 feet to 250 feet. Or the KD Cat HD 500 with the KD HD 8x8 BT matrix switcher, you go from 300 feet to 400 feet. When we talk about 1080i or even 720p, of course, carries a similar bandwidth. We're looking at 100 feet for the HDMSW 4x4, 280 feet for the HDMS 4x4 with the BBTX, BBRX, or the BBs in one-to-one usage, even the Cat HDX as well, or all the way up to 500 feet using KD Cat HD 500 or KD HD 8x8 BT in a 1080i system. Okay, up to 500 feet. With that, I guess we'll say these are the third-party Cat 6 shielded cabling distances. As we use the key digital cabling, you can see again we're going to pay some immediate dividends, going from 100 feet, going from 280 feet to 300 feet, going from 500 feet to 600 feet. So if and when you have the opportunity to use the key digital cabling, you see there's definitely a lot to gain from doing that. If this is a new build, you're going to have the opportunity to run the proper infrastructure for an HDMI system. Or even if it's not a new build, but you have the option of running new cabling. The walls are down, or maybe it's a commercial space with really no drywall to rip out, that sort of thing. In the residential applications, you may not have so much flexibility, unfortunately, when they have very expensive wallpaper on the wall that they are wanting to protect. The other remaining portion of the analog versus digital question is the analog sunset, also known as the digital sunrise. You're beginning to see a fair amount of sources these days that are HDCP, copyright protected and encrypted sources that only feature HDMI connections. For example, right now you've got your Apple TV, the first generation Apple TV, featured HDMI and component outputs. But after that first generation, it's strictly an HDMI connection now. So that's just one example of this sort of source that has copyright protection and only features an HDMI connection. Now that we've discussed this, you know that you're not able to downconvert that HDMI source to analog if it is encrypted with copyright protection. Okay, so if your client really wants to integrate this sort of source into the system, well, you know there's only one way to go with it, and that's going to be digital. When do you go analog? Well, currently budgetary reasons may factor into going analog versus going digital. As you can see with the KD HD MSW 4x4 HDMI matrix kit, with the receive balance and the HDMI cables, Key Digital actually has some very cost-effective solutions out there, and it's not to say you can't find other things for even less. But currently, right now, the analog products of a similar I/O configuration are typically going to be found at a lesser price point, than the HDMI comparable I/O configurations. Long-range distances. So we talked about the distances that are possible in the 1080p realm and the half bandwidth resolution realm for HDMI. In the analog realm, as a reminder, with Key Digital Active Balance, you could go up to 1,000 feet. Now, if for your best picture quality in those long runs, let's say at 500 feet and beyond, especially for your VGA signals where you have your video signal split into 5 different leads and your color can become separated more easily, the skew problems that we discussed, you're going to want to use that Cat 6 STP1X. So now you see it's not only for the digital applications, but using that Key Digital Cat 6 STP1X shielded cat cabling with the minimal twisting, it gives you increased distance, increased quality, and also the fact that the cabling, each of the 4 pairs is at the same twist. actually provides images without as much ghosting as your traditional cabling, where they're all four at different twist levels. If you have that existing infrastructure or a retrofit application like we're talking about, hey, I'm sorry, Mr. Customer, if you want HDMI, we're going to have to be able to go through some of these walls in some places, and you've got this expensive wallpaper here. I'm sorry, it's not going to be much chance for us to put in the new infrastructure to enable this kind of system. This might be a factor. This might be a situation you may be confronted with. Very large systems, very large systems. Of course, with HDMI, you could go large, okay? At some point, I'd say right now there are some systems that are only possible in the analog world, okay? However, even if it were a scenario where you could do an 8 by 32, for example, in the HDMI realm, or 8 by 40 beyond, in the analog world, price, of course, is going to be much less for that analog of a similar I/O configuration. And then once we go beyond some of those numbers, you're really looking at scenarios where the very large systems, for example, your sports bar systems, where you may have 16 by 64, it's going to be either extremely expensive to go HDMI with that, or just not at all possible to go HDMI with it. And relative picture quality resolution, what do we mean by that? Well, everything is relative. Everything is in the eye of the beholder, as the saying goes. And what looks like the best picture to me may not look like the best picture to your client. Now, we in the industry, in the video side of the industry especially, have what I would consider to be a critical eye, trained eyes, knowing what to look for that are the indicators that this picture is of good quality. For example, when it comes, for example, the question of 720p versus 1080i, that especially is going to be something that's relative. As we've discussed, the bandwidth is comparable. It's just a matter of, do you want more horizontal lines of resolution but only get every other picture and have it alternating, or do you want a progressive picture with every line during each frame? Now, when it comes to the question of, does HDMI look better than an analog signal, I think, again, everything's relative, I think that the answer is yes, okay? I think a digital signal does look better than an analog signal. But again, especially in the VGA versus component, there's going to be scenarios where it might be acceptable to the customer to go with that VGA system versus the HDMI system. So let's go ahead and begin creating some of these full circle systems. System design example 1. Now, as it says here, we're going to design entire solutions using key digital product categories. So we know that the matrix, for example, is going to be the centerpiece in many of these systems, but as you'll often find, it's not just having that matrix there, it's having the piece on the front end and the pieces on the back end to deliver the systems as demanded by the client. So here's an application where we had a church, a house of worship, that had 6 video sources with 7 video displays, and they wanted to integrate them all together. When you have many sources with many displays, you're going to be going with a matrix switcher. The video sources are a variety of formats, with VGA being the majority rather. So the variety of formats pretty much means you're going to have to do your formatting up front, and we'll take a look at that when we see the actual design. Now you know, though, you are going to need a video processor. They have CAT cabling going to each display, requiring CAT bound devices. Some CAT runs are going to exceed 500 feet. We're going to want to go with the KD Cat6 SDP 1X cabling in that instance to ensure we're delivering optimum picture quality, especially in a church where a lot of projectors or large screen displays are going to be utilized. So let's take a look. Here are our 6 sources and our 7 displays. Your PC, for example, in the top left corner, you'll note there we have a ×3. So if you're looking and say, I only see 4 sources, what's going on here? That dedicated PC, we have 3 of them. Those are VGA. We know that VGA is the majority rules of this system, if you will. So we're going to go ahead, it's safe to say, we're going to plug in those VGA sources directly in to the matrix. And we know that on the display side, each of them has a VGA connection as well. Converting and scaling of video sources. For example, our camera control, our DVD, and our auxiliary port source equipment is component, or the auxiliary is going to be a plate, it looks like, that has a number of formats. In those cases, we'll utilize our KD-VP1250. The point here is that we know we're going to the displays, the projectors and the flat panels, and we're going to connect to them with a VGA connection. So ideally, you're going to format up front everything to one single format. Why do we do that? Well, what's the alternative? The alternative is having a single scaler at each and every display versus having just 3 scalers total in the system and having that up front. Okay? Our final requirement, extension to each display via CAT cabling, in which case the KD-CVARX is the balun, as you know now, that must be used with the KD-MSW CAT 8x8. We go ahead and we're going to be using the KD Cat6 STP1X cabling so that we are able to deliver skew-free video without the information arriving at different times, resulting in those skew problems that would happen if you were using standard CAT cabling to go those distances. System design example number 2. Another church needing a solution that allows them to feed one HDMI presentation laptop to 2 projectors. So this is just a single source with more than one output, which is an ideal application for a distribution amplifier. One projector features VGA input and the other features HDMI input. So not all churches are going to have huge budgets. Some of them will. I can think of a few applications where churches have budgets for the AV system alone upward of $7 to $10 million, for example. These are some of your, of course, mega churches, if you will. But not all churches are that way. Not all churches are that way, and you might have to accommodate what they have. For example, they're not buying 2 new projectors. They're obviously working with one projector that is existing. They don't want to upgrade that yet, and it has VGA input, not HDMI, whereas the presentation laptop looks like it has HDMI. So when we're going to do the format conversion, we're going to be using a video processor, and they'd like to extend video to each of these 2 projectors via CAT cabling, which will require, of course, that CAT cable and also the balun device. Let's take a look at how it comes out on paper here based on our system design group's recommendation. Requirement number 1 was one source to be viewed on many displays. Again, one-to-many distribution amplifier. Here we're utilizing the KD HDDA 1x2 HDMI distribution amp, one source, 2 displays, one in, 2 outs. Requirement number 2, scaling your HDMI format to VGA. We have the 2 outputs of the HDDA 1x2 at this point. We know that one of the projectors needs that end result, that end format connectivity to be VGA. So we're going to go out of one of the HDMI connections into this KD-VP1250. And finally, requirement number 3, extending video via CAT cabling to each projector. Let's go ahead and drop in our KD Cat HD-X HDMI over dual CAT balun pair. Very cost effective. Very good means of getting from point A to point B, so long as you're within the distance requirements, of course. And using to extend VGA signals, the KD Cat CVA, also sold as a pair, supports component or VGA, even supports audio to that projector as well. Now this is possible so long as your content or your source connection is not HDCP encrypted. If this laptop became a Blu-ray player, obviously that would be encrypted with copyright protected content, the content rather would be encrypted with protection, and therefore our VP1250 would not be able to deliver this sort of conversion from digital to analog. But in the case of non-HDCP, this is certainly within the rules. System design example number 3 brings us to a bar and restaurant. They would like to integrate 16 component video sources with 40 displays. 16 by 40. We're going to be utilizing a matrix switcher. They'd like to extend video to each display via cat cabling, and as we look at these zones, it looks like some distances are within 150 feet, some distances are greater than 150 feet. So we're going to be utilizing cat balance rather in any case, but let's take a look here and go ahead and look at the requirements and the gear we're going to utilize to fulfill those requirements. Requirement number 1 is the requirement of many sources to be viewed on many displays, in which case we are going to utilize a matrix switcher. This is going to be the KD MSV 16 by 40. Again, we talked about the MSV being very active in the sports bar and restaurant applications. It is a matrix switcher of video only, MSV, matrix switch video. So there's no audio through it, which is typically acceptable in the bar and restaurant application because they're most likely going to be utilizing some multi-zone audio amplifiers. Especially in a system like this, you're going to have a few zones of audio, and that's typically going to be handled separately from this video system we're putting together. Requirement number 2 is extending video via cat cabling, in which we know we're going to be utilizing passive balance for distances that are less than or equal to 150 feet. So earlier we were talking about 500 feet and beyond, going with not only an active balun, but having that skew-free cabling, the Super Cat 6 cable that we offer. In this case, we're going to go with the KD-Cat RCAA, which is 4 RCAs, meaning RCA with the component video and a single analog audio lead, because we're really not using audio here, so you don't need stereo, you don't need digital. This is just the skew that most appropriately fits the application for those runs under 150 feet. And for the runs over 150 feet, we're going to go with the KD-Cat CVA. So really, this is another question of relativity, let's say, of the picture quality. But say, if you want to deliver best picture quality, generally speaking, 150 feet is a good guideline as a means of going with passive or going with an active balun. Again, active balun, KD-Cat CVA, we saw it earlier, supports not only VGA but also component, also could support analog audio if you'd like, and they do require power on both ends where the passive do not, so there's certainly advantages of having a passive balun if you're limited on ports to supply power to these active baluns. Let's go ahead and take a look at system design example number 4, which is another bar and restaurant solution where we have more of a reasonable, let's say, I/O relationships. We have 8 inputs, 24 outputs, which many to many will require a video matrix switch. They'd like to be able to select any of the sources to supply the audio for 3 independent audio zones. So we're going to be utilizing the audio matrix switch that we offer as well. Let's go ahead and take a look as it breaks out. We see what we're starting with. We know is going to be some satellite boxes, some cable boxes. We have here the displays on the right-hand side. We're going to need the matrix switcher. 8 inputs, 24 outputs is going to accommodate what we have here. We have our audio zones as well, and the audio sources are going to feed into the KD MSA 8x8 Pro audio matrix. And what's nice about this is the MSA 8x8 Pro features the volume control, for example, the EQ, the audio control of the muting, for example, per output. So really your amplifier, if you'd like to somewhat streamline the feature set of that amplifier, not having to pay the extra bucks to buy the amplifier with the volume control, etc., it's all built into our MSA 8x8 Pro. So it's going to go in as left and right, line level audio, and of course leave that amplifier third party. At this point, Key Digital does not offer an amplifier, leaving that amplifier as speaker level audio. Here is system design example number 5, which is a gymnasium. This is a gymnasium that would like a solution allowing 3 displays to view 6 video sources, including video conferencing plugin throughout the gym. When we have many sources and many displays, we're going to use a matrix switcher. The majority of the sources are actually component video. 1 source is VGA, As we know, that means we're going to need a video processor anytime we have to format sources. They'd like the displays to receive HDMI 1080p video. So this is interesting. Why is this interesting? Because the sources are component. The sources, one source is VGA. Okay, none of these sources are HDMI. Okay, so we're going to have to kind of do some creative thinking here with this one. You're going to see how it all comes together here in just a moment. But you know, for that sort of conversion formats and resolutions, again, video processor is going to be necessary. And cat cabling is wired to each projector, which is our 3 displays. So we're going to be utilizing cat bound devices. So here are our sources. You actually have plates, component plug-in plates, okay, as well as a DVD player. And you have a Mac computer with a VGA connection on it. Requirement number 1, many video sources to be viewed on many displays. Of course, that's going to be a matrix switcher, okay? That's going to be a matrix switcher. In this case, we're just handling video only, so KD MSB 8x8 standalone single unit is going to be an ideal fit for this. Requirement number 2, scaling of each video output to HDMI 1080p. So that's the output to the projectors again. That's what they want to be projecting, is a 1080p content to those screens. And the source scaling, let's not forget the Mac is VGA, also needing to be converted. So here we go. Here's our solution here. We're going to not only have the scaler on the source side with the Mac, but also on the 3 outputs. And this is just a matter of evaluating. For example, if we wanted to scale every source, we would need 6 VP1250s. If we wanted to, because we have 3 projectors, we know that really we only need to scale 3 output signals, plus of course we need the 4th scaler for conversion of VGA to component. And now, since the scalars are on the output side, it's always going to be an incoming component video feed, and it's always going to output to the projector via the cat bound here, which is our requirement number 3, to the projector via HDMI at 1080p video, which the VP1250 enables, scaling from incoming component to outgoing HDMI at 1080p. Okay, so as we look at system design example number 6, this is going to be an emergency operations center that would like a solution enabling 4 displays to view any of the 10 video sources. So this is a bit of a converse statement from, say, the sports bar applications, where typically you have maybe 8, maybe 16 sources with 24, 40 displays, as we showed earlier there. Of course, these numbers are flexible, but the emergency operations center, you may have a smaller amount of operators of the viewing stations, if you will, than the sources, because your sources are going to come from all sorts of media feeds, etc. But nonetheless, you still require a matrix switcher, and we know that this is going to be a custom configuration matrix switcher as well, due to the numbers we're dealing with. 4 component video sources will need to be converted to VGA, requiring a video processor. Cat cabling is wired to each projector, requiring bound devices. So as we take a look at the sources here, we see cable and DVD, for example, are component video sources. We see that the local PC alone, we have 4 local PCs. We have central PC, podium PC, okay? So we see here now, VGA, without a doubt, is the majority of the source devices. And since obviously these projectors support VGA in, that's going to be our majority rules format connectivity for this system. So many video sources to be viewed on many video displays will require a matrix switcher. In this case, because we've exceeded 8 sources, we're going to go with the custom configuration of the KD MSW CAT 16 by 8 in this case. Requirement number 2, scaling of the component video sources to become VGA. Again, VP1250, it is a Swiss Army knife. It is used in all of these applications here. And finally, extending video via cat cabling to the projectors will require bound devices. Again, as we learned earlier, KD CBARX is the default bound, marrying in with the KD MSW CAT matrix switcher family, even in the custom configuration case. So we have 1 per display. They are sold a la carte. Therefore, your equipment list for this system is quantity 1 of KD-MSW CAT 16 by 8, quantity 2 of the KD VP1250s, and quantity 4 of the KD CVA RX. Looking here at the example number 6, which is a sports bar that would like a solution enabling 64 displays to view 8 sources. So another scenario with a sports bar where you have quite a bit of displays, not so many sources. That is nonetheless going to require a matrix switcher. Here's something pretty custom they want to do here for this application. Each matrix output will be distributed to 8 mirrored displays. So they're okay with 8 displays always viewing the same thing at the same time. After all, if you only have 8 sources, you have 64 displays. Well, you know that there's going to be a bit of redundancy going on throughout the system. So what they're going to do, take one of the outputs of the matrix, feed it into a distribution amplifier, and then get to the displays using cat cabling, which will of course require cat-bound devices. Let's take a look at the system as it was laid out by Key Digital's system design group. Requirement number 1, many video sources to be viewed on many video displays. Many displays, of course, with many sources requires a matrix switcher. Again, an ideal application for the KD MSV 8x8, feeding in the component video. Requirement number 2, this is again that custom curveball again, if you will, where we don't want to go to each of these 64 displays directly. Instead, they want to go first using one of the 8 outputs of the matrix switcher, because again, we're only using the 8x8 here, not the 8x64. We're going to go output to some distribution amplifiers. In this case, we're going to be utilizing the KD Cat DA4TX for 2 reasons. One, it is our de facto analog matrix switcher, analog distribution amplifier. Reason number 2 is that we know we have the cat cabling. The KD CVA-RX will marry in with, sorry for speeding ahead here, the KD CVA-RX marries in cleanly with the cat DA4TX, so no need to have additional transmit bounds. This distribution amplifier is the transmit bound. And actually, even a third reason why we go with the cat DA4TX is it has loop through. So the cat DA4TX has 4 outputs. We needed 8, if you recall. 64 displays, 8 outputs of the matrix. Therefore, we need 8 outputs per matrix. And because that cat DA4TX has that loop through, you are able to cascade from one unit to the next, from unit 1 to unit 2, as we show you here, and deliver 8 displays from a single matrix output. As we see here, the requirement number 3 of the system was the audio matrix, many audio sources to be heard in many audio zones. So we're going to go with the matrix. And finally, the extending of the signals via the bounds. As we know now, the cat DA4TX has the cat port built in. Just one other reason why it is the ideal piece for this application. Proceeding to system design example number 6. Here we're looking at a residential application where that customer would like a solution enabling 24 displays to view up to 8 sources. We're going to be utilizing a matrix switcher. Again, another custom configuration where you have to order that custom SKU so that we configure it for you here in the Key Digital factory. We're going to extend video to each display via cat cabling. That'll use our bound devices. Let's go ahead and start populating this system design. We start with what's on the outside, the sources and the displays. Requirement number 1, many video sources to be viewed on many displays. Of course, many-to-many requires a matrix switcher. KD MSW Cat 8x24 features cat built in. So now as we go to the extending control and video via cat cabling, we're going to utilize the KD CVA-RX to extend and marry in cleanly with that matrix switcher. No need for the additional transmitters built in to that equipment rack. It is part of the matrix, if you will. They are built in as the outputs of that matrix. Now, this is the first example we've shown here where we're actually utilizing the control routing feature of the Key Digital hardware. So you see here, we have the total of 4 ports going into the matrix switcher. 4 ports going into the matrix switcher, 4 green arrows from your control processor. What are they? Well, on unit number 1, the master of the system, you're going to want to give us 1 control port to control the system. So it actually, 1 control port handles all of the switching through the 3 units required to enable this sort of 8x24 configuration. The second lead feeding into the matrix is going to be an IR lead to control displays 1 through 8. Similarly, units 2, units 3 are also being fed an IR lead to control your displays 9 through 16 and 17 through 24 respectively. And again, for information on how that was achieved with the KD MSW-CAT 8x24 and the KD CVA-RX, go ahead and take a look again at section 2.1, 2 part 1. Amplifier here. This is the means of getting the audio to each zone. This is a third-party amplifier. The client told us we're using this amplifier. We go ahead, and as long as we've got room and we don't see any issues with showing this piece of equipment on our system design, we usually will be happy, more than happy in fact, to go ahead and populate that on the design for you. System design example number 8 is a digital signage application that would like a solution distributing an HDMI video source to 8 displays. They're all going to show an identical, aka mirrored image. They're all going to show the same thing at the same time, which is the need for a distribution amplifier. There's actually not just one source of this system though, there are actually 4 selectable sources, but again we want them, all the displays, to show the same thing at the same time. So if you combine a switcher and a distribution amplifier, you're able to achieve this at a much more cost-effective price point than utilizing a matrix switcher. One of the sources is a computer with VGA output, whereas we said here in bullet point number 1, we want an HDMI system. Therefore, we're going to need a video processor, and they like to extend everything, video and control, via CAT cabling. Let's go ahead and take a look in closer depth here. Requirement number 1, identical mirrored displays. We know there's going to be a distribution amplifier in this system. We have the perfect fit for that for your 8 display system, which is the KD-HDDA 1x8. Requirement number 2, selecting one of the 4 sources. Well, that's going to require a switcher, a simple 4x1 HDMI switcher. Our model number KD-HDSW 4x1, again, an ideal fit. Our 3 HDMI sources are going to feed right in there. And requirement number 3, converting that PC to VGA, with VGA to become an HDMI source, is going to require our KD VP1250. Now that we've gone in VGA to the 1250, we can go out HDMI, feeding that 4x1, making it one of the 4 selectable sources. Requirement number 4 is extending video and control to the displays via CAT cabling. So we've got the video handled with the KD CAT HDX. We know how that works. We also have 3.5mm plug, enabling the extension of IR or unidirectional RS-232. In this case, it looks like the format is IR. And actually, we're going to utilize a key digital part that we haven't discussed much throughout these trainings, which is the KD IR Kit 300. Your basic IR distribution block allows us to basically just have a single control feed. Maybe all these displays in this system are all the same manufacturer, all the same manufacturer of the display. For example, a Sony, Toshiba, LG, Samsung, they usually generically one remote, even from a few years ago, will still work with most functionalities, power on, power off, for example, with even their current lineup, and even from series to series, the remotes are pretty standard. So just one discrete IR signal being split basically up to 12 ways with the IR Kit 300 would make this work. System design example number 9. Customer would like a solution distributing an HDMI video source to many monitors showing an identical image. Okay, again, just like before, identical image with a single, it sounds like a single HDMI video source. It's going to be a distribution amplifier. Each monitor of the system, though, has a local video source in addition to the distributed source. So what we're telling you here is that at each of these viewing monitors, yes, they want to view this head-end display from time to time, but then there's also a local video source that they'd like to be able to toggle between, if you will, almost as an A/B switch, and as I just said, requiring a switcher. They'd like to extend the video from the main distribution point to the main distribution point, I should say, via Cat cabling. We're going to take a look at this picture here of the system design, and it will all come together for you, my friends. Let's start with what we have, what we know we have, which is the presenter PC. We got that over on your left-hand side at the head end. We know there's also a local PC. That's our local video source for each of these 40 displays. And we know we have all the way on the right hand side, we know we have 40 displays. So let's go ahead and start looking at the requirements and the solutions to satisfy each of those requirements. Requirement number 1, identical mirrored displays, meaning we're going to have distribution amplifiers. In this case, we're going to have a few distribution amplifiers, 6 to be precise, KD HDDA 1x8. So you see here, this is a tree method, if you will, where you have the head end KD HDDA 1x8, and it has, of course, 8 outputs. Looks like here we're utilizing 5 of those 8 outputs, feeding yet another HDDA 1x8, which essentially 5 times 8 equals 40 displays. 40 outputs are going to be able to receive this initial head-end video signal. Requirement number 2 is selecting the local source, in this case the local PC, or the system source, in this case the presenter's PC. How do we do that? We're going to, each display is going to be integrated with a KD HDSW 2x1 switcher, allowing that, again, A/B switch. Am I viewing the presenter's PC? Am I viewing the local PC? Requirement number 3, extending the video to the main DA via Cat cabling. So this is the presenter PC, and what we're seeing here actually is that this DA is not at the same location as that presenter PC. So they need a means of getting that content from presenter PC to this initial HDDA 1x8 so that it can begin this tree method distribution. We're going to utilize KD Cat HDX to do that, but then you also see we're utilizing KD-HDDA 1x1 as well. Why are we using KD-HDDA 1x1? Well, just for the reasons we discussed on this previously, the signal repair, for example. As you go over KD Cat HDX, that is a bound that features equalization, but before you're going to split this thing 40 ways, it's a good idea to go ahead and reclock that signal, make it brand new again before we go ahead and feed that HDDA 1x8. So this was actually a system that was a design I was involved with at a higher learning facility. This was a library at a college where there were 40 kiosks, if you will, 40 cubicles, I suppose would be the more appropriate term to refer to them as. And for the most part, you're doing your own work at these cubicles. However, a few times a week they did have this presenter come in, and so instead of having this sort of these presentations in your more typical presentation style rooms, theater style rooms, for example, they wanted to do this in the library, so this was a good means of right there, right in front of that person sitting at the cubicle. Instead of looking at the projector, you could look at the presentation right there in that cubicle. Proceeding now to system design, example number 10. Customer would like an HDMI matrix solution enabling 5 sources to be viewed on 3 displays. We know the many-to-many requires an HDMI matrix switcher. They'd like to extend video, audio, and control. Video, audio, and control via Cat cabling is not only going to require bound devices, but also going to require Cat6 shielded cabling because we want it to marry in with this matrix. So let's take a look here. Our 5 sources, DirecTV 1, 2, and 3, Blu-ray, and PC. Okay, this PC has HDMI output. Requirement number 1, providing access to any of those 3 displays to any of the 5 sources at any given time is going to be a perfect application and really a flagship application for our KD HDMS 4x4-5x3. -5x3 is a custom configuration. Because of that card slot flexibility again that we discussed in level 2 part 2, you know that HDMS 4x4 can be any possible configuration that totals 8. Anything from 1x7 to 7x1 can be fulfilled with this part, and actually there's a big advantage of that, as we could see it here, because if you needed more than 4 ins or 4 outs, for example, we have the 5 displays that are able to be connected to this matrix. If you need more than 4 ins or 4 outs with other companies' products, you typically, to this day, to my knowledge, you will have to go to their 8x8 chassis product. In the Hercules series HDMS 4x4's case, it's not necessary. You could stick with the 4x4 price point, the 4x4 chassis size, etc., and achieve it with the 5x3 configuration. Second is extending video, audio, and control via Cat cabling, and for that we're going to utilize the KD BBRX single Cat 6 shielded product and the KD Cat 6 STP1X and the KD RJ45SC to complement it for our shielded Cat 6 cabling runs. And now we're looking at distances actually all the way up to 200 feet or 250 feet rather for 1080p. Here we have the HDMI plus the IR or RS-232 all through the Hercules series as the hub. And again, as a reminder, the advanced control routing features of the Hercules and the Digital IQ series HDMI matrix parts is going to be a topic we explore in more depth in level 3. System design example number 11 brings us to a solution that would require 4 HDMI video sources to be viewed on 4 displays and an AV receiver. So 4 televisions, if you will, and an AV receiver. We know we're going to need a matrix switcher because we have many sources and many displays. Each display will be integrated via Cat cabling. We're going to use Cat bound devices to do that. And since we have that AV receiver that is going to be utilized to provide multi-channel audio to one of the zones there, anytime you deal with that AV receiver, there's again possibility of handshaking issues or signal strength issues. It's a good idea to utilize the KD HDDA 1x1 for some signal correction. Requirement number 1, matrix switcher. Many sources we have here, many displays as well. Now also, because it is the HDMSW 4x4, we're going to go ahead and show how we feed in the control ports from this control system, the simple IR control block or control system. We're going to feed in 4 control ports into IR control ports 1, 2, 3, and 4 on the matrix, and it's going to allow us to control those televisions as well. Extending to each display via Cat cabling, we're going to go ahead and go with the KD Cat HD 4x4 RX. Now you see they're not itemized on this system design. That's because they are included, again, with that KD-HDMSW 4x4. It's a kit, matrix, 4 receive bands, 8 HDMI cables, all in that box for that SKU. Requirement number 3 is making sure that AV receiver is going to work well for us. Of course, HDMSW 4x4, as we've shown you, has the EDID library, but let's just go ahead and, for good measure, install the connection to that AV receiver with the HDDA 1x1, just to make sure everything is well there. It's not going to be something that, when installed, breaks the bank on the application. System design, example number 12, is a residential installation that needs a solution allowing them to view multiple sources in multiple zones with left-right audio outputs. We're going to require a matrix switcher. They'd like to extend video from each projector via UTP Cat cabling. Excuse me, there's a typo here. They'd like to extend video to each projector via Cat cabling. Okay, shouldn't say from to. that was a little confusing there. That's going to require. Excellent. As we proceed now to system design, example number 12 is a residential installation. Needs a solution allowing them to view multiple sources in multiple zones with left-right audio outputs. That's a very important request here, and you'll see why in a moment. But we know that it will require a matrix switcher because of the need for many sources to many displays. They would like to extend video to each display via UTP cat cabling. And, so this looks like a scenario where you don't really have the option to upgrade the cat cabling to Cat 6 shielded. Nonetheless, it will require a Balun device. Let's go ahead and take a look here. We got 4 zones of audio, which is the reason why we need that left-right analog audio output. We got our 4 displays and our 4 video sources, 4 sources with HDMI out and 4 displays with HDMI in. To fulfill requirement number 1, many sources to many displays, HDMS 4x4 is ideal. 4 sources, 4 displays, not to mention the fact that each output has the left and right analog audio there available, making it perfect for those applications where you want to view the television on the walls while always using the audio in the ceiling. Okay, that's a very common request here and a huge reason for the success of this Hercules series product. Requirement number 2 is extending video via the cat cabling, which is unshielded twisted pair. So if you have HDMS 4x4 and you don't have Cat 6 shielded, you're okay. You could use the KD Cat HDX, for example. How does this work? You utilize the HDMI output ports on the HDMS 4x4. You are not able to utilize the RJ45 output port on the HDMS 4x4. Okay, so this is basically how it works. So the advantage of the left-right audio port, I suppose, for this customer, this installer, was greater than the fact that he'd have to have some additional transmit side baluns located there in the equipment rack with him. When utilizing the Cat HDX, he had 2 cat cables, and this is traditionally how your how your matrix systems would work in the past, where you didn't have the cat integrated into the matrix. Okay, so this is how this piece comes together. System design example number 13 is a customer who would like a solution integrating many HDMI video sources, again, to many HDMI displays. That's going to require a matrix switcher. Each display will be integrated via cat cabling, where you have cat Balun devices. 2 sources are analog with VGA output. You know that means when you have format that is not on par with the rest of the source formats, we're going to require some video processing to occur. Requirement number 1, many to many, requires a matrix switcher. In this case, we're going to utilize KD HDMS W4x4, and I've gone ahead here and connected the baluns that are included with that HDMS W4x4 at this point. Those are included in that kit in the box. Requirement number 2, extending via cat cabling. Now here is something rather custom that you can offer with the Key Digital line of HDMI matrix. You can, as we just shown, utilize the HDMI output to feed external baluns, the baluns that are not included in the matrix, okay? As the matrix does feature the RJ45 ports, of course. And yet you can do them at the same time if you'd like. For example, we have our projector and the 70-inch mirrored TV, the identical TV, not the TVs that are hidden behind the mirror looking very nice. This is an identical TV, so this is obviously some sort of daytime, nighttime setup, okay, or training room setup, depending on, yes, actually this application, that's right, it was a training room setup. And sometimes they use the projector, sometimes they use that flat panel, but they're never using the same thing at the same time. Therefore, it's okay that you have these 2 displays receiving the same feed at the same time. And of course, another factor in this, not only the fact that it's acceptable in this case to have them receive the same signal at the same time, when would you go with the Cat HDX versus the built-in Balun of the HDMS W4x4? Distance. Distance as well. It can also be a factor, as you have heard a few times now. We'll say it one more time. The HDMS W4x4, the baluns included in that are limited to 75 feet at 1080p, 100 feet to 1080i, where the Cat HDX is distances of 140 feet 1080p, approximately 280 feet 1080i 720p. And now we have source conversion, our VGA computer, our document camera, also VGA, going into that HDMI system. We're going to need to do that formatting up front, therefore utilizing 2 of the KD VP1250s, 1 per source. And here's those distances right there if you'd like to take a note. System design example number 14 is going to be another look at HDMI matrix systems, where you have a residential application this time with many sources, many displays, requiring a matrix switch. They'd like to extend video and control to each display via Cat cabling. Some zones will have UTP cabling, requiring dual Cat balance. Of course, any of our HDMI balance working over UTP cabling require 2 Cat cables, and some zones will only have STP cabling available, meaning those walls are able to be opened, or maybe it's a new build within this application. So again, you have lots of flexibility there because we do have the HDMI and the RJ45 ports active. So as we take a look here, requirement number 1, many sources, many displays. This is going to be an application for our KD HD 8x8 BT. Now, one thing you will notice is that there are greater than 8 displays to the system. How is that all going to come together, you wonder? Well, take a second and you will find out. Requirement number 2, extending to each of these displays via Cat cabling. And it looks like 8 of those primary displays are in the zones where we have the option, or we do not have the option to run new Cat cabling. So we're going to go with the KD Cat HDX. It should be noted that we also have a plate in the case that you need to use these Cat HDXs, for example, in your equipment rack, and you're concerned, I really wish it could look nice, clean, as it would if I were just plugging in that RJ45 into the 8x8 BT matrix switcher. Not to worry, we do have a KD-RK150 PLT. That's KD, of course, like Key Digital Romeo Kilo 150, P like Papa, L like Lima, T like Tango. That is a plate for the rack that houses up to 8 balance. Now, it looks like these additional displays, though, they are just fine with them showing the same thing at the same time. They just want to have them as part of the systems. And this is a great opportunity for you to say, hey, Mr. Customer, you're building this new section of your home or of this application, and we got the opportunity here to run that wire. Why don't we hang those TVs on the wall? Why don't you let us sell us those televisions? And go ahead and set those up to the system there, where maybe these lesser used zones, or these zones where it is okay that they're going to be viewing the same thing at the same time as another zone, now can be integrated into the system. Proceeding now to system design example number 15 is another case of the many-to-manys, where you have many HDMI video sources to be viewed on many displays, requiring a matrix switcher. Now you're going to see here this one is rather large. Therefore, each source will need to be distributed to each of 3 matrix systems, okay? So you're familiar here from level 2.1 how we achieve large-scale matrix systems in the analog world. You're going to see how we achieve large-scale matrix systems in the digital world here within just a moment, a picture of that. But in order to do that, you are going to need some distribution amplifiers. So we here have, looks like a limited amount of sources. This is 3 video sources. And we have 36 displays. Yeah, 36 displays of this system, okay? So let's take a look here. Many sources to be viewed on many displays requires a matrix switcher. What kind of matrix switcher I/O configuration are we going to use is the question, and that is going to be our KD-HD 8x8 BT as a 4x36 configuration. How is that possible? 4x36. Well, it relies on the distributing of those sources to the matrix systems to enable this large configuration. So let's go ahead and make that connectivity here, and now I'll take a second to explain it. 4x36, well, you know that the HD 8x8 BT is a product that is available in any configuration from 15x1 all the way up to 1x15 and vice versa. This specific application because we need 36 displays and we have a limited amount of sources, which is 3. We're going to go ahead. You have two options there. You could do configuration of 3 by 13. So again, that totals 16. So not 8 by 8, but 3 by 13. Anything that totals 16, of course, flies. 3 by 13 times 3 could get us to 3 by 39. This looked like it was an application where the customer said, you know what, they're definitely not going to be adding any more displays down the road, but they might want to add another source, so let's give them that opportunity if they'd like. Therefore, we set up these 3 matrix systems as 4 by 12, okay? 3 4 by 12 matrix switchers, and now here's how this works. You've got source number 1, in this case the DVD player, feeds distribution amplifier number 1, and these distribution amplifiers are 1 by 3, of course, because we have 3 matrix systems to feed them into. So for source number 1, as you follow these orange lines leaving that matrix switcher, that distribution amplifier, source number 1 feeds distribution amp number 1. Output 1 of that distribution amp feeds the matrix on the top there. We'll call it matrix 1, and that's going to feed your outputs 1 through 12. Output 2 of the DA feeds matrix 2, going to feed your outputs 13 through 24. And output 3 of that DA feeds matrix number 3, feeding outputs 25 through 36. And we'll see it here, where you have your displays. If you follow the black line for cat cable, we didn't really separate as much here, but that's okay. It's if you start at the top with the displays there, you can see that you have 3 rows, three displays per row, and we have 4 rows of 3, giving us 12 displays because it is a 12 output matrix. So displays number 1 through 12 are fed through matrix 1. So essentially this is a means where in the analog world you use Y cabling to achieve these large-scale systems. You of course cannot use Y cables in the HDMI world, but using a distribution amplifier is the means that at Key Digital we utilize to build some of these large-scale systems. And it actually turns out fantastic. We've done a large amount of these systems here like this, and there's some great advantages when you get to this sort of configuration with, say, beyond 32 outputs, or even anywhere beyond 16 outputs right now. Seems to be a big price advantage leaning towards Key Digital, because with an application like this, if you needed 36 displays independently, of course we do have that video wall, and those 9 displays at the 3 by 3 video wall are able to be viewing in video wall mode or individually, independently, as you can see that we're feeding them 9 independent feeds. If you have this sort of system where you have 36 outputs required, with other manufacturers, that usually means you're going to have to go to a 64 output matrix system, and that's not only strike number 1. Strike number 2 is that typically the chassis supports up to 64 inputs as well, which, hey, in some applications that might be necessary. Obviously in this application you can see that it's not, and it therefore creates a large pricing advantage that favors Key Digital versus the competition. All right, very well. So that was 15 design examples covering a wide spectrum of application types, from your residential installations, small and large, digital and analog, to commercial applications such as the common house of worship, the sports bar and restaurant applications. We covered some emergency operations center applications. You saw some conference room applications, digital signage applications, etc. And really this is just a small glimpse of what we do here. Actually, as a note, every single one of those system designs was collected by our system design group, or collected from our system design group, I should say. So when you come to Key Digital expecting or offering, looking for assistance with your upcoming application, you can expect a very professional looking design, something that clearly explains the application and how Key Digital's parts are able to enable that. Okay? So that was level 2, part 3. full circle system designs, where we went ahead and took the information from level 2 part 1, which pertained to analog systems and the products we used to build those, and level 2 part 2 pertained to HDMI digital systems and the parts we used to build those. We got you in the gear of thinking like a key digital SDG expert, system design group expert. What does an SDG expert think? Well, the first thing they're going to do as soon as you tell them that, hey, I need some help speccing out a system, they're going to go for the information they need. What are the displays and how many? For example, we saw projectors. We saw AV receivers treated as displays. We saw flat panels. Of course, we deal with a variety, okay? What are the sources? How many of each? What are the distances? Or at least give us the maximum distance. It might be a determining factor in, is this going to be a digital system or is this going to be an analog system? Or if it is a digital system, which balun are we going to use, etc. What is the what is the desired format or resolution of the system, and how would you like to control the system? Again, these are the information. These are the information we understand from the beginning. How do we enable that with the Key Digital gear in the middle? Is the questions that you're coming to Key Digital for. Okay, so usually you have the outside, don't you? You have the outside, as we saw there. What's in the middle making this thing happen? Okay, we discussed, when do you go digital? For example, distances less than or equal to 600 feet. It's an amazing number for me. I'm just in awe, to be honest. In awe of the fact that Key Digital is able to deliver you HDMI at 600 feet via cat cabling. Because 3 to 4 years ago, the number was about 50 feet. 50 feet we were able to deliver cat cabling via HDMI bounds, or even up to 100 feet at a half bandwidth resolution. So say 100 feet versus 600 feet now. Boy, the technology has come a long, long way, hasn't it? So the distances, do you have the opportunity to run the proper infrastructure? We cannot stress enough how important infrastructure is, meaning the cabling, in the HDMI world. It should be of high integrity. It should not have any patch bays, splicing, keystones, coupling, etc. You want to avoid that at all costs if possible, and certainly you want to disclose that information to Key Digital when we're building the system for you, because we want to deliver a system that's going to work for you. Also, you consider any of the sources that the customer of yours is bent on installing into the system, or any of those sources, what we call analog sunset type sources with that copyright protection encrypted. If it is, we have no choice but sticking in the digital realm. We cannot convert that signal to analog, okay? When do you go analog? Budgetary reasons. Runs up to 1,000 feet, so those runs that go beyond 600 feet, certainly we're not going to have much option outside of going analog or getting creative, okay? So that's why you go to the system design group, okay? Retrofit applications, where that infrastructure perhaps is not able to be upgraded to Cat 6 shielded, for example, or perhaps there are some factors such as coupling, etc., that would be a little more kind to an analog type system. Large-scale systems, we certainly saw a few of those, a few examples of those with the sports bars, for example, in the previous designs. And also relativity. Your customer may say, we need to be able to perform this, 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 and this. And if you deliver it in VGA, it looks fine to me, okay? We don't need anything HDMI, we don't need this, we don't need that. And instead of over-delivering on that, basically you can deliver something in the analog realm. Hey, that's just one example of the basically how everything is relative, isn't it? So that was level 2 part 3, and actually that concludes level 2 for us. So congratulations, you've now viewed all of the content of level 2. Of course, make sure you please complete your exams for the level 2 so that you can become fully certified on level 2. And level 3 is going to be, level 3 part 1 is going to be the next thing we're going to view here, which is advanced HDMI matrix configuration and setup. So this is what we've alluded to, for example, in the level 2 part 2, a few of the advanced features and some of the things we promised we'd go into more depth into. It's going to begin in level 3. And that should do it. So thanks again for spending your time with us. And we appreciate your efforts at educating yourselves on Key Digital. Again, for any questions, please email training@keydigital.com, or of course refer to Level 1 Part 1, where we had a wide variety of other contacts and resources here at Key Digital we're able to offer you, available to you there. Thanks again, and have a fantastic day.